Objective 7, be able to write and use molar ratios to predict yield. So I have two examples for you. First one says calculate the mass of carbon dioxide formed by burning 1 gram of methane. So I'm going to assume you could come up with the balanced equation of CH4 plus 2O2 yields CO2 plus 2H2O. So then the work begins when you take your 1 gram of CH4 and you multiply that by 1 mole per 16.05 grams. So you divide by the molar mass basically here. And you find out that you've got 0.0623 moles of, this is my CH4. So then I can convert that to moles of CO2 by noticing that I have a 1-to-1 ratio between CO2 and CH4. So this is also 0.0623 moles of CO2. And so now to get my mass of that, I can multiply by the 44.01 grams per mole in CO2. And when I do that, I come up with a mass equal to 2.74 grams. So that one's pretty straightforward. The second one I have for you says given 2NH3, 3CuO, N2, 3Cu, 3H2O, so you've got the balanced equation. If excess ammonia, so my limiting reactants could be this copper oxide, is reacted with 90.4 grams of copper 2 oxide, predict the mass of copper that should form and the volume of each gas that should be produced. And I need to add here at STP because you need some conditions to predict the volume. So we'll make it simple. So I've got 90.4 grams of copper oxide. So when I divide by the molar mass, copper oxide is going to be the 63.55 plus the 16, so 79.55 grams. That's going to give me a molar amount for copper of 1.14 moles. And I'm going to have to use that for all three problems here. So 1.14 moles of copper, if I'm sorry, that's the copper oxide. If that's how much copper oxide and that's my limiting reactant, and I want to know how many grams of copper, I need to look at the molar ratio between copper and copper oxide, and it's 3:3. So that's also how many moles of copper I have, 1.14 moles of copper. So finding the mass of copper, I just take it times the 63.55 grams per mole, and I should expect to get 72.21, I think it is, around 72 grams of copper. As far as my gases, 1.14 moles of CuO. If I look at my nitrogen first, that's in a 1-to-3 ratio. So this will be cut down to only 0.38 moles of N2. And N2 has a molar mass of, I'm sorry, I don't even want the molar mass. And N2 at any gas, if I have 0.38 moles, if it's at STP, is going to occupy 22.7 liters per mole. So when I go ahead and multiply that, I would expect 8.63 liters of my N2. And then finally, my 1.14 moles of CuO compared to my other gas is also a 3-to-3 ratio, 3 moles of water for 3 moles of CuO. So this is still going to be 1.14 moles, and since it's also at STP, I can expect 22.7 liters per mole. So now my moles could be, or my volume is going to be 3 times as much at 25.9 liters of H2O.